Algebra 2, Chapter 3.1, Quadratic Functions in Vertex Form. Homework. These will be exercises 1 through 11. I'm going to go over the odd number problems in this set. Number 1. For function f of x equals a times quantity x minus h squared plus k, f of h plus 5 equals negative 19, and f of h minus 2 equals negative 4. Find f of h minus 5 and f of h plus 2 is a positive or negative. Explain. So one thing we have for the vertex of a quadratic function in this vertex form is going to be, the vertex is going to be the point h comma k, or when you have, they write like this, h comma f of h. So if we plug in to the function the value of h, our output, that'll be the y coordinate. One way you can look at this is to create a table, and we have x and we have f of x. Well, the point h comma k is the vertex. I'm going to put this right in the middle of the table. So we have h, and we're going to have f of h as our output. And as we go to the right of that value of h, whatever it is, we will have f of h. We have h plus 1. We have f of h plus 1. And so on. Now, in this case, we're given f of h plus 5. We don't know what that is, but I'm going to come down and put in h plus 5. F of h plus 5 equals negative 19. And because of symmetry of a quadratic function, we can come up here to equidistance away from h. We're going to put h minus 5, and f of h minus 5, because we're equidistance away, is also going to be negative 19. And then we're given f of h minus 2. Well, here up above is h minus 1, h minus 2. Well, that's going to be negative 4. And so therefore, f of h plus 2, because of the symmetry, is going to be also negative 4. And so what this looks like when we graph it is this. We have an xy coordinate plane, say xy, and we're going to have a vertical line here, which is going to be the equation x equals h. And we don't know exactly where it is, but if we go to the left, actually f of x plus 5, so we go right 5 from h, 2, 3, 4, 5, our output value is going to be negative 19. So we'll have this point here. And because of symmetry, f of h minus 5, we go to the left 5, 2, 3, 4, 5. We're also going to get negative 19. So we know those 2 points. Now we go to f of h minus 2. So we're going to go to the 2 to the left, and we have negative 4. So go 2 to the left, we have negative 4. And we have 2 to the right, we're also going to have f of h plus 2 is negative 4. So we know, we don't know exactly where it is, but we know that our vertex is going to have to be somewhere up above. So the general shape of what we're looking at in our parabola is going to be like this. Try to not get very, yeah, it looks something like this. So what do we know? Well, we have a downward opening parabola, so A is going to be less than 0, and how to explain, because what's the way to articulate this? The closer we get to the vertex, let's put it this way, the closer we get to H, f of H becomes greater. Okay, next, what is, find f of H minus 5? Well, f of H minus 5 is going to be the same as f of H plus 5, and that's going to be equal to negative 19. F of H plus 2 is going to be equal to f of H minus 2, which is equal to negative 4. So those would be our answers to problem number 1. I find that making a table and making a sketch of a graph are going to be corroborative things that help us understand what's going on here. Let's go on to the next algebra problem, which is 3. Identify the axis of symmetry, then give the function's maximum, minimum value, domain, range, and intervals with functions increasing or decreasing. Well, again, we go to standard form of a quadratic function, which is going to be f of x equals a times quantity x minus h squared plus k. And so our vertex is going to be the coordinate pair h comma k. And so because of this, let's go ahead and examine what we have here. Well, a is going to be equal to negative 7. H is going to be equal to 8 because we have x minus 8. So h is equal to 8. And finally, k is equal to 1. So let's answer the questions. The vertex, being the coordinate pair h comma k, is going to be 8 comma 1. So therefore, our axis of symmetry is going to be the equation x is equal to 8. Next, maximum or minimum value. Well, a is negative, so that means we're going to have, I'm just going to make a sketch of it over here. We have the xy coordinate plane, So we have 8 units to the right. That's our axis symmetry. We have our vertex is going to be right up here at 8, comma 1. And so the graph of function is going to look like this, increasing all the way up to x equals 8 and decreasing after x equals 8. So that's what it's going to look like. And so we'll say we have maximum value of 1 where x equals 8. And domain. The domain of all quadratic functions is all real numbers, which in interval notation is going to be greater than negative infinity or less than infinity. Range we have greater than negative infinity up to and including 1. So that would be that in interval notation. Where the function is increasing and decreasing, we'll say that f of x is increasing on the interval from greater than negative infinity to x equals 8. And then f of x is decreasing on the interval from 8 to less than infinity. So that's going to be that. So quite a few things here. Those will be our answers. Okay, next on the problem 5. Here we have, let's put down what they are. A is equal to 2. And here we have x plus 2, which means h has to be negative 2. We have to get x plus 2, we have to have x minus negative 2. So h is equal to negative 2. K is equal to 9. So our vertex for this quadratic function is going to be the coordinate pair negative 2, comma 9. So that means our axis symmetry is going to be the line x equals negative 2. Now, since a is greater than 0, we have a minimum and it is 9 where x is equal to negative 2. And then if we make a sketch of this, we have our x equals negative 2. That's our axis symmetry. And we have a minimum at the coordinate pair negative 2, comma 9. And then we have an upward opening parabola since a is greater than 0. And so we can say, let's get our domain here first. We have all real numbers greater than negative infinity, less than infinity. We have our range. We have our range is going to be, we have a minimum value of 9 to x is less than, or y is less than infinity. And finally, f of x is decreasing on the interval from negative infinity to -2. And f of x is increasing on the interval from -2, greater than -2, to less than infinity. So that is it. Next on the problem 7 here. This exercise set has to do with writing the quadratic function in vertex form by completing the square, then identify the maximum minimum value and the value of x at which it occurs. So basically what we're trying to do is focus in on number 7. We have f(x) equals x squared plus 6x. We want to add to x squared plus 6x what we need to create a perfect square. And to do that, put f of x equals, we're going to put in parentheses here, x squared plus 6x plus what we need to complete that square. And then outside, we're going to subtract that same amount that we find inside to complete the square. And at the very end, we're going to subtract, we're going to bring that -3 down here. So what we do is we're going to take that middle term of 6x and take its coefficient 6, divide that by 2, and we're going to get 3. And then we take that 3 and square it to get 9. So 9 is what we have to add to x squared and 6x to make a perfect square out of it. And having added that 9 inside the parentheses here, we're going to have to subtract that 9 again outside the parentheses to keep this equation balanced on the right side. So now we are in position to write our vertex form. A is 1 here because the coefficient is 1, so we have x plus 3, 20x plus 3 squared. And outside parentheses we have -9 minus 3, so we're going to put -12. And so we completed the square, and A is greater than 0. So we have, there's a minimum of -12 where x is equal to, remember we have this f of x equals a times quantity x minus h squared plus k. So we have +3, and so h has to be -3. So there will be our vertex form and our minimum and where that minimum occurs. Okay, let's go on to next on problem 9. We have f of x equals 3x squared plus 24x plus 53. And so with 3x squared, we have some additional complexity that we didn't have before. What we're going to do is factor out a 3 from 3x squared and also from 24x. So we're going to rewrite this function as f of x equals 3 times quantity x squared, and we factored out a 3 from 24x, we're going to get plus 8x. And then we put plus blank, and our blank is going to be what we're going to have to add to complete this square. And then on the outside, we're going to subtract the same thing that we added inside the parentheses here. And then finally, we're going to bring down this 53. Now, what are we going to put inside the parentheses? Well, we take our coefficient of x, which is 8, divide it by 2, and we get 4. We take that value 4, square it, and we get 16. So 16 is what's going to have to go inside the parentheses to create a perfect square. Now, we can go put negative 16 over here, but would that do the job for us? No, it would not. Why will it not? It's because when we put 16 inside with our perfect square, we're still multiplying that 16 by 3. So what we have to do is really subtract on the outside, not 16, but rather 3 times 16. So now our equation is balanced. So f of x is equal to 3 times quantity x plus 4 squared. And on the outside, we have negative 3 times 16. That should be negative 48. Negative 48 plus 53, that's going to be plus 5. So this will be our completed square version. And since a is greater than 0, we have a minimum. We have a minimum of 5, because when we have h comma k, we have the vertex of this parabola is going to be the coordinate pair negative 4 comma 5. Minimum 4, and that's going to occur where x is equal to negative 4. So that's that one. Okay, the last problem we're going to look at in this exercise set is this real world problem. Multi-step. The height h above the roadway of the main cable Golden Gate Bridge can be modeled by the function h of x equals 1/9000th x squared minus 7/15th x plus 500, where x is the distance in feet from the left tower. So basically, when we look at this tower here, we're considering this as a coordinate plane. I'm drawing out like a y-axis, and the x-axis is along the roadway here. So x and y is what that looks like. Complete the square to write the function in vertex form. Well, we're going to do similar to what we did in problem 7 and 9. We'll write h of x, and we're going to factor this 1/9000th away from the x squared. So now we put in parentheses x squared. Now we have minus, we factor out the 1/9000th from this 7/15th x. what we have to do is multiply 7/15 by 9,000. So let's go ahead and do that in our calculator. So 7/15 times 9,000, we get 4,200. So we're going to have minus 4,200x. And then we're going to have plus some number here, which we're going to find. And then we're going to have subtract that same number outside here. And then finally add 500 at the end. So it's the same principle we used before for problem 7 and 9, but the numbers are smaller or larger depending on how you look at it. So let's go ahead to the right and take this 4,200, that coefficient of x, and divide that by 2. And for that we get 2,100. Now we're going to get a few million. 1,000 squared is a million, so we're going to get 4 point something million. So let's go find out what that is. So we put in 2,100 squared. We get 4,410,000. So 4,410,000. And as we put in here, now on the outside, are we going to subtract 4,410,000? Well, what we have to do is we have to put in 4,410,000 divided by 9,000. So let's do that in the calculator. So we divide by 9,000, and we get 490. So on the outside we put minus 490. And now let's just go ahead and write this out. H of x equals 1/9,000. And we're going to put in our perfect square, x plus, actually minus 2,100 and squared on the outside, and then we have minus 490 plus 500, so we have plus 10. So that will be our vertex form. What is a vertex and what does it represent? Well, again, a vertex is the coordinate pair h, k. And in this instance, we have a vertex of h is 2,100 and k is 10. So what we have is right here is the point pair 2,100, 10. And the vertex is the lowest point in the bridge span, in the cable span, h above the main cable. So vertex is coordinate pair 2,100, 10, and is the lowest point in the cable span. Okay, that's that one here. Next, the left and right towers have the same height. What is the distance in feet between them? Explain. Well, here we have at x equals 0, if we plug in 0 to the original equation, we get a height of 500. Well, because of symmetry, if we come to the right 2,100 feet and go another 2,100 feet, we're going to get the point 4,200, comma 500. So the distance between them is 4,200 feet, because you can say it a number of ways. The equation tells us so, because of the second tower being 2,100 feet beyond the vertex of the parabola. So that's really going to be it. So a lot of bigger numbers to work with. That really shouldn't be too intimidating. I hope this can help you. Good luck, and thanks for viewing.